Google's Pacific Connect initiative is an extensive project to enhance internet connectivity across the Pacific region. The initiative involves laying undersea cables to connect various countries and improve their internet infrastructure. A total of 7 cables will be laid across or between the US, Fiji, French Polynesia, the Commonwealth of Northern Mariana Islands, Guam, New Zealand, and Australia. The South Pacific Connect initiative will deliver new international subsea cables connecting Fiji and French Polynesia to both the US and Australia. It will have 9 branching units for other Pacific Island countries and territories to connect to. The aim is to increase the reliability and resilience of digital connectivity in the Pacific. Tabua is named after a polished tooth of a sperm whale and is an important cultural item in Fijian society. Tabua will connect the United States and Australia to Fiji. The cable will be more than 12,000 kilometers long and will be laid in depths up to 6,000 meters deep. It will begin in Los Angeles, pass through Suva, and end in Sydney. Through the cable, industries such as business process outsourcing will be strengthened and will enable new projects such as Google's $200 million data center to operate. Fiji expresses its profound gratitude to Google for this collaboration and reaffirms its unwavering commitment to support this transformative initiative, dedicated to fostering peace, prosperity, and a brighter future for our people and the broader global community. This was the remark from the Prime Minister of Fiji, Honorable Sitiveni Rabuka. Hanamoana in Polynesian means link, Hano, and ocean, Moana. The subsea cable will connect the United States and Australia to French Polynesia. Like the Tabua subsea cable, the Hanamoana is a trans-Pacific cable that will begin in Los Angeles, pass through Papineau in French Polynesia, and have endpoints in Auckland, New Zealand, Sydney, and Melbourne in Australia. According to the Aquacom's website, which tracks submarine cable networks, both the Tabua and Hanamoana subsea cables will be ready for service by 2026. The interlink between Fiji and French Polynesia is called the South Pacific Interlink. Its main purpose is to connect the two island nations and provide additional redundancy. The expected date of completion is 2026. Google has partnered with several telecommunications companies to deliver the Tabua and Hanamoana subsea cables. Its partners are Fiji International Telecommunications, Office of Posts and Telecommunications of French Polynesia, AP Telecom, and Vasus Group. The Central Pacific Connect initiative will deliver 2 new intra-Pacific cables, Bulicula and Halihai. The aim is to increase digital connectivity in the Pacific. Google's partners in this initiative are Amalgamated Telecom Holdings, AP Telecom, and Telstra. Bulicula subsea cable will connect Guam with Fiji. Bulicula is the Fijian word for the golden cowrie, a rare shell found in the Pacific Ocean worn by local chieftains as a badge of rank and cultural significance. The Bulicula subsea cable will be about 5,000 kilometers long and will run from Suva in Fiji to Tanguasin Point in Guam. The Halihai subsea cable will link Guam and French Polynesia. The subsea cable will run from Tanguasin Point in Guam to Papineau in French Polynesia, a distance of 8,000 kilometers. The term Halihai is used by the Chamorros, the indigenous people of the Mariana Islands, in the expression telephone Halihai to refer to information being spread from person to person. The Halihai subsea cable is named after a vine that grows on the beaches and is pantropic across the Asia-Pacific. The Central Pacific Connect initiative will create a ring between Guam, French Polynesia, and Fiji. This ring will include 5 pre-positioned branching units, allowing other countries and territories of Oceania to take advantage of the reliability and resilience resulting from the initiative. Once operational, Bulicula and Halihai will join Guam's existing subsea cable portfolio, including Apricot, Echo, and TPU, Taiwan, Philippines, US. The expansion of the Pacific Connect initiative is an additional $1 billion investment to connect Japan to North America and the Pacific. The initiative will see 2 additional cables being built, namely the PROA and Taihei Subsea cables. The cables will create new fiber optic routes between the continental United States and Japan in support of Google's Japan Digitization Initiative. This will improve the reliability and resilience of digital connectivity between the United States, Japan, and multiple Pacific Island countries and territories. Google will be partnering with KDDI, Arteria, Citadel Pacific, and the Commonwealth of Northern Mariana Islands to deliver the cables. As can be seen, this will create a web of subsea cables to further increase reliability in the region. The NEC-owned cable system, the Taiwan-Philippines-United States Subsea Cable, also known as the TPU, will be extended to the Commonwealth of Northern Mariana Islands. As the Commonwealth of Northern Mariana Islands' first international subsea cables, PROA and TPU will together establish a new route between the continental United States and Shima, Japan. The PROA subsea cable is named after an ocean-going canoe used by Marianas, the native inhabitants of Guam. The subsea cable from Google's partner NEC will connect Japan, the Commonwealth of Northern Mariana Islands, and Guam. The Taihei subsea cable is named after the Japanese word for both peace and Pacific Ocean. It is another NEC cable that will connect Japan to Hawaii. Additionally, the Tabua subsea cable will be extended to Hawaii, building on the plans announced last year to run the cable from the continental US to Fiji and Australia. Once complete, the Taihei and Tabua systems will create a diverse path between the continental US to Takahashi, Japan. Google will also fund the construction of 2 interlink cables, one connecting Hawaii and Guam, and the other connecting the Commonwealth of Northern Mariana Island with Guam. The 2 interlinks will connect the Trans-Pacific routes, improving their reliability and reducing latency for users in the Pacific Islands and around the world. In addition to Google's Connect Pacific and Connect Japan initiative, Google is planning on connecting South America to the Pacific. The Humboldt will be the first subsea cable to connect South America and the Asia-Pacific. It will link Australia, French Polynesia, and Chile. It will be 7,800 kilometers in length and will begin at Valparaiso in Chile and end in Papinoo in French Polynesia. It will have 3 branching units. When operational, the Humboldt will strengthen the reliability and resilience of digital connectivity across the Pacific by interconnecting the cables that comprise the South Pacific Connect initiative. The Humboldt cable is named after Alexander von Humboldt, a German polymath, geographer, naturalist, and explorer who traveled extensively to the Americas at the turn of the 19th century. Looking at a map, my country's location at the center of the Great Pacific Ocean spells connectivity. I am therefore enthusiastic that Google has chosen to add Guam and Chile to the growing hub of submarine cables connected to Tahiti. A world better connected is a better world. This was the remark from the president of French Polynesia, Motai Brotherson. Google has not provided technical information for the Pacific Connect initiative. It is understood that information such as bandwidth, latency, download, and upload speeds will not be available until after project completion in 2026. However, we can deduce from their last projects to make assumptions. 2 of their recent projects are the Topaz and Grace Hopper subsea cable projects. The Topaz project, which connects Japan to Canada, was completed last year. Here is a video from the Google Cloud team talking about the technical aspects of the Topaz project.
Let's take Topaz, one of our newest subsea cables. It's the only cable in existence to directly connect Canada to Asia. Its planning started over 5 years ago. Predicting capacity and building a cable isn't easy. I got to meet the teams that made it happen.
What we do is we try to look at our current requirements from the business and then try to predict what the demand would be, say, from now to the next 5 years out. Cloud customers not only have an increasing appetite for more and more bandwidth, but they also want this bandwidth with certain latency guarantees. By adding more diverse cables, they're essentially increasing the reliability of the bandwidth that we can offer them.
So Google Cloud has become a big part of the equation. But what about increasing the capacity of the fiber itself?
That's where my team comes in. Obviously, replicating a 10,000 kilometer subsea cable in a lab is pretty difficult. We do have fiber optic spools that are about 80 kilometers long, and we actually daisy chain these fiber optic spools together to try to replicate a Google Cloud network. This optical spectrum analyzer shows 4 lasers. Each is carrying 400 gigabits of network capacity per second. And in total, that's 1.6 terabits of zeros and ones.
That's a lot of data to fit through a fiber the width of a human hair. But another way to increase capacity is to squeeze more fiber pairs into a cable. In 2020, we were able to fit 16 fiber pairs into the Grace Hopper cable, instead of the usual 6 or 8. That cable can transmit 340 terabits of data per second, enough to stream this video in 4K 4.5 million times simultaneously. One of the final steps to laying a new cable is making sure we have the most up-to-date electronics in place to power it. And we've made some impressive enhancements to Topaz. A wavelength selective switch for resilient and dynamic paths was first sketched on a Google whiteboard over 4 years ago. Now this innovation is being implemented in Topaz and adopted across the industry.
In the very early days of subsea technology, a submarine cable was simply something that went from one point to another point. The wavelength selective switch allows us to effectively carve up the spectrum on an optical fiber pair, use some for this purpose, use some for another purpose, in order to expand the capability. End users benefit from our ability to redirect traffic on the fly.
So if a new customer demands more capacity, we can run commands from a computer and traffic shows up quickly in a different place. Pretty powerful, right?
A cable like Topaz doesn't just improve reliability between Canada and Japan, it improves reliability of the entire network. Google's network operates like a mesh. Our organization focuses on creating solutions that interconnect humanity, and that's really the purpose of our network. Our highest priority is to create a network that society can depend on.
It all comes together on a momentous day at shore. Teams all over the world collaborate to stretch our network fabric through an enormous feat of partnership, physics, and engineering. It's our network that makes Google Cloud ready for the next wave.
The Topaz network can carry up to 340 terabits per second on its 16 fiber pair cable. Each fiber is the size of a human hair. The fibers are wrapped around a layer of protective coating, and the final cable size is that of a garden hose. The cables utilize wavelength selective switches to regulate transfer of data. A wavelength selective switch is run by a software and acts like a traffic light. It redirects traffic in a given wavelength spectrum on a cable fiber pair to be used for certain purposes. For example, video streaming can be handled by one wavelength of light, while another wavelength handles downloading. For comparison, the Manatuas subsea cable carries 2 fiber pairs and connects Samoa, Niue, Rarotonga and Aitutaki in the Cook Islands and Tahiti and Bora Bora in French Polynesia. Each fiber pair will be capable of operating at up to 10 terabits per second, which means its maximum bandwidth is 20 terabits per second. This is less than 10% of the bandwidth of the South Pacific Connect Initiative subsea cables. Also, the Coral Sea cable, which connects Australia, Papua New Guinea, and the Solomon Islands, is a 4-pair fiber optic core that carries a maximum of 40 terabits per second. The cable then splits into 2 at a branching unit in the Coral Sea. The Coral Sea cable is just 12% of the assumed capacity of the Tabua and Hanamoana subsea cables. What Google is doing in the Oceania, Asia, and Latin American regions is commendable. By improving international connectivity, subsea cables help drive economic growth in terms of gross domestic product and job creation. Greater network capacity and lower latency enable businesses and public sector organizations to deliver better digital experiences to their customers and constituents, and people gain skills and knowledge that open career paths. This will be one of the greatest technology projects that spans the Pacific and will be a blessing for the inhabitants of the Pacific.